Hello everyone, and welcome to another Highcrafters recap session. I believe this is number 7. So last week what we did is we built a circuit using everything you learned in the lecture before that, which was actually a lot of stuff. So I hope you're not too confused at this point. If you are, go ahead and back up to that lecture. I think that's number 5, recap video number 5. So if you are confused up till this point and you have questions, watch recap session video number 5, and it covers how to build circuits. It covers all the components in your circuit, your Arduino kit that you have. So make sure you're not confused on stuff. Today we're actually going to be moving into a brand new topic, coding. So we're actually going to be learning how to code the Arduino itself. Now this could be a long video, so I may break this actually up into 2 videos rather than trying to do it for like a half an hour to 45 minutes, because there's an awful lot that goes into coding. So this is a recap session, and you will probably get confused because what we're going to be talking about today can be some confusing stuff. There's a lot of stuff that goes into coding. So if you are confused, as always, you can watch this video again. You can go to the Slack chat, you can send me an email, go to the website, the contact page. There's lots of ways to get help, and you can check out the Arduino forums as well. So let's go ahead and get into a little bit of coding. Okay, so let's start to get into some of the coding that goes behind the Arduino. So in class, what we did to start off is we installed the Arduino IDE. Now, this is another one of those acronyms. So we have the letters I, D, and E. And out of all those I'm sorry, it's so messy. Out of all those letters, I usually when I come to acronyms, I like to try and pick one letter, or sometimes 2 in the case of HTML, and pick one letter that will help me remember what this acronym stands for. So in this case, I like to pick the letter E, and the E there stands for environment. Environment. Don't make me spell it out because it's horrible here. Okay, so the environment is the word that helps me kind of remember what this whole thing means, and really that means that this is the Arduino IDE is our coding environment. It's where we're going to do all of our coding from. So we should get very comfortable inside of our coding environment. Okay, so when you first open up your Arduino IDE, you're going to see a few lines of code at the beginning that are already in there. So some of the most important ones, and really all the way at the beginning, you're going to see void setup. And pardon my, there we go. New day with a new pen. First day with a new pen. So, okay, so you have void setup, and then you have curly Q and end curly Q. So everything that is between these 2 curly Qs, these 2, belongs and is a part of this void setup. So anything that is there, when I say put it inside of void setup, I mean put it between these 2 curly Qs. So that's what I mean by that. Okay. So I just want to get that idea. So void setup, and then you can see actually the comment here says place your setup code here to run once. So let's talk a little bit more about what void setup does. So the code that you place in here is only going to run once. And this is where you define the Arduino pins as either an input or an output. And that might be something to write down. This is where you define them as an input or an output. And it's done like so. So let's talk about a little bit about what's going on with this line here. Pin mode 13 output. What are we doing there? So essentially, pin mode, I like to think of pin mode as what I'm going to call a command. Okay, so that's your Arduino command. And then we have the pin number that we are assigning or defining, as I have up there. And then we have our input or output. Is it an input or is it an output? Which one of these? And in this case, it's an output. Sorry about that. Yeah, so in this case, it would be an output that's going to go there. So that's really the breakdown of what that line is doing. So that's defining this pin 13 as an output. Alright, so hopefully that makes some sense. Now, again, like I said earlier, the code that's placed in between here and here, all this code, there's probably going to be a lot more lines once you start doing more programming, but that code is going to be run only once, and that happens as soon as the Arduino board is plugged in. So as soon as it's gotten power to it, or as soon as it's gotten 5 volts. Okay? Alright. So, now we move into void loop. Oh, and I should mention, I'm sorry about this, but I should mention we're going to talk about what this whole input and output deal is. We talk about that a lot more in class. So if you don't know what that is at this point, don't worry about that. We talk about that, and if you're confused, you can talk to me about that in the Slack chat, about what the difference is between an input and an output. All right. So after you've after you've put your code in void setup, you're going to find the lines that you see here, which is void loop. And again, I'm sorry for my writing. Try this again. Void loop, and a start curly Q, and an end curly Q, curly bracket, whatever. And all the code that's placed inside of here, all this code, you could have tons of lines of code. Okay, all that code gets run on a loop forever and ever and ever until the Arduino is powered off. I like to think of it this way. Imagine we've got a couple lines of code, right? And we have a little guy here, and all my students have called this guy Jerry. Okay, so we've got Jerry here, and Jerry is the little guy inside of your Arduino board who's reading all your code. Alright, so Jerry goes down the code, reads each line, moves to the next one, and then goes back up, and imagine this is the same code, and he reads it all over again, and then he comes back and he reads it, and he keeps doing that over and over and over until the Arduino board has no power. So that's the idea. Now, the idea I do want to get across today is that between this loop and the next loop, this little gap here is actually a gap, and there is a small, tiny little millisecond where there is a bit of a gap there, and the program or the Arduino pretty much just pauses there. So if we had a piece of code that said turn an LED on, and you could say that there's really only one line, and that line says turn on an LED. So that's what we have there. And let's say it repeats forever and ever. So here's Jerry. There's Jerry. And Jerry reads that line, goes back up, reads it again, goes back up, reads it again, goes back up, and forever and ever until the Arduino is turned off. So you notice this little gap here. In each of these gaps where Jerry has stopped reading and is going back up to the top and is going to read it again, in each of those gaps there's actually a bit of a pause. So if we had a high-speed camera, we would actually see the LED pause or turn off and then on again. So it would actually be more of a blinking than it would be a constant on. But because the computer thinks way faster than our eyes can see, we don't actually see that pause in there. So hopefully that makes sense. Okay. So all the code, like I just said, that we place in void loop is going to run repeatedly. So this is actually the line of code I was talking about earlier. This line will actually turn an LED on, in this case the LED that's on pin 13, and we're going to talk more about digital write in a minute, but just know that this line will continually make an LED stay on. Alright, so far we've gone over the structure of an Arduino sketch, and we've actually gone through this rather quickly. So now what we're going to do is we're going to go over the actual code part, the meat of the sandwich, if you will. So for the rest of this class, we're going to be using the example code you're going to see on the next slide. If you were not at class and did not receive this handout, please let me know through the Slack chat or through piecrafters.com through the contact page, and I can get you that handout really quickly because this is rather hard to read, but I think you can actually read a little bit of it. You've got INT pot pin equals 2, INT LED pin equals 8, and so on. Okay, we're going to go through this handout in the next 2 or 3 lessons, and this is probably going to be one of the most important handouts you've received so far this semester. Okay, so in order to break down what this handout is doing and to understand what's going on here with the code, we have to know a few things. And the first thing is actually what's at the very, very beginning, and that's INT pot pin equals 2, INT LED pin equals 8, and INT val equals 0. And I've put all these out here so that you can see them. So that's what's at the very top of your handouts, above void setup. So these are called variables, and variables are strings of letters that are assigned a value. Okay, so let me just, another way I like to think of a variable is a container. So I'm really bad at drawing, but let me try and make this as good as possible. Imagine that's a cup, okay, and this is, I should really rethink my drawing abilities here. Here is the name of the cup, and let's call it A. And so inside of A, we're going to put a couple red balls. Let's say we put 4 red balls inside that cup. I'm sorry, I'm so bad at this. All right. So now, whenever we we have that cup A. Let's say we just created that. So now, here's our code. Every time I write the word A, or the letter A, more importantly, every time I write A, what am I actually saying? Pause this video and see if you can guess what I'm actually saying. Okay, so what I'm actually saying is I am saying 4 red balls. So every time A is mentioned here, doesn't matter where, that's what I'm saying it is. It's 4 red balls. So 4 red balls, 4, you get the idea. Okay, so that's what a variable is. I like to think of it as a container that can hold certain values, and that's actually what we're doing here. So let's move into how we create this and all the stuff that goes into this. So the INT part, what does that mean? Well, the INT I like to think stands for integer, helps me remember it. And the variable name is then created right after the INT. So let's go back to the previous slide really quickly. And I want you to notice that we have INT for each of these. So we have INT, INT, and INT 3 times. And then what's right after it, pot pin, that's the name of our variable. LED pin, another name for a variable. Val, another name. Okay? All right, so now that we have that, let's move on. And then the number right after that name, remember I underlined it in red, whatever the number is after that name is the Arduino pin number that we are attaching to that variable. That's the value we're going to assign to that variable name. Okay, so the variable name can be anything you want it to be. The only rule is that you can't have 2 or more variables with the same name. So let me show you this again. We're going to go back to that slide. So we have our INT pot pin, INT LED pin, and INT val. Those could be whatever I wanted to name them. I just chose to name this pot pin because I'm actually attaching this to a potentiometer. And I chose to name this LED pin because I'm attaching it to an LED. And I chose to call this val, well, you're going to see why I called it val later. Now, there is a bit of a typo. This should say A2. And hopefully on your handouts, it does. If it does not say A2, write that in. Should say capital A2. That's really bad handwriting, but I am trying to do this on the tablet, so it's a little tricky. All right, so that should say A2. So again, what we're doing is we are naming our variable. We have to create it first. So we're creating a variable. Then we're naming our variable. Then we're assigning it a value. In this case, we're assigning it the value of 2. Down here, we are creating a variable, int, naming our variable. This could be whatever we want it to be. Then we are assigning it the value of 8. We're attaching it to pin 8. Or, if you like to think of my cup analogy, this is our cup. Okay, we're putting pin 8 inside of it, and we're naming it LED pin. That's the name. So now every time I say LED pin, what am I saying? Well, I'm saying 8. So hopefully that makes sense, that container idea. All right, so there is hopefully variables all summed up for you. I hope variables make a bit more sense now. If they don't, maybe watch this one more time just to kind of get what I'm talking about. If that doesn't help, please shoot me an email or Slack chat or whatever. I don't want you to be confused at this point because it's only going to get harder from here. Okay, so we talked about variables, talked about ints. One thing we have not talked about yet, and that's rather important, is const ints. Const. C-O-N-S-T. Const ints. Okay, so const ints are the same pretty much in principle, but just a little different. Const, well, first we should start with regular ints. So regular ints, if we gave it a value here at the top, say int, whoops, see int a is equal to 9. And that's at the beginning of our code. Later on in our code, if we changed it and said a is equal to 10, we could do that. And we could change a from 9 to now equal 10. Okay? Because it's a regular int. Now, if instead I made this, and give me a second, bear with me. If instead, and I think I'll keep 9 here, I made this a const int, okay, and I have my semicolon. Now later on in the code, if I tried to say a is equal to 10, it would say, you can't do that, no, 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 alright, and it would stop us and say, nope, this is a constant, which means constants never change, they're constantly going to be the same, or whatever value we set up here at the top. So if, let me redo this because it got a little messy and smudged up here. So if instead I said const int a is equal to 9, right? Then later on in the code, I tried to change it, a equals 11 or whatever you want to change it to, right? That would not work. But if I went up here to the top and I changed it to 7, well then, now it's 7. This line still would not work, but I can change it up here. This is the only place, on this line is the only place I can change it. Alright, I know I scribbled a lot. I hope that makes sense instead of adding confusion, but hope you understand the idea behind constants. Okay, constant ints now. Alright? Okay, so in the example sketch, whenever we wanted to use an Arduino pin, we used it by referencing it with a variable. Okay, and take a look at your handout and see, notice where we use that. So every time we said LED pin, or one of those pins at the top, which is pot pin, LED pin, and val, notice wherever we use that, okay, we are actually using a variable there, right? We're using that variable name, and we are instead using the variable rather than using the pin number itself. So it's actually a bit of a better way to do code, and I'm going to try and explain this to you in a little bit. So in the setup, okay, earlier we talked about how pin modes work, right? We said pin mode is here, and then we had, I believe it was 8 before, and then we had output. Well, in this case, it's actually, the code is identical to what we had before, except rather than putting 8 here, we put LED pin. But if you look on your handout, it's actually the same. LED pin is equal to 8. So when I say LED pin, I'm actually saying pin 8, and then I'm assigning it output. So this code, the result of this code is actually the exact same as the result before we started using variables. Okay, so why use variables? Well, there's a lot of different reasons. Let me go into one of them right now. Now this is going to take a little bit, so just bear with me for a second. So let's imagine I have a lot of code written here, and every time I write a number, I'm actually using a pin. And let's say, in this case, I'm using pin 8. So now, let's say, I tried to upload this code to my Arduino board and it wouldn't work for some reason because pin 8 is being used by something else, or pin 8 is on the wrong side of the board and I just don't want to use pin 8. Well, guess what? I'd have to go back through all my code, scratch it out, write in, let's say I wanted to use pin 9, even though it's right next to it for some reason. Pin 9 works, but pin 8 doesn't. I don't know why. So I'd have to go through all this code, cross out the 8, write 9. Okay, that's a lot of work. And as programmers, being redundant is not a good thing, and we are very lazy at heart. So going back and changing all this code is a lot of work, and not to mention you're probably going to miss one or two of these. So it's a lot of work for something that doesn't need to be done. Well, how can we get around this? Let me get rid of all this and show you a proper way to code. At the top, if I had instead done this, it would have been much, much better. Oops. Let's stick with our color scheme. Const int, and I'm just going to call it 8 because, or a, because I just want to. Const int a equals 9. Okay, and then I went through my code, and rather than using the pin number, I use a. So now, if I wanted to change all that, I wouldn't have to change every single one of them. I just change this 9 to a 7 or whatever I want to change it to, and now every single one of these, all of them, have been changed to 7. So hopefully that's a good example of why variables are so useful and why we really like to use them, and why you should use them rather than putting pin numbers. The least amount of times that you can put pin numbers, the better, in my opinion, because using variables is a lot more efficient, and it makes a lot more sense in this case. Okay, so that's how variables work and why we use them. Oops, sorry about that. Okay, so again, this is how you use them. You replace the number the pin number with the variable name itself. Okay, and we're going to get into this in a minute. Alright, so we went over an awful lot of stuff in this video. And this is, I decided to split this up into 2 parts actually, because there's just so much to go through. And actually it looks like it's going to be more like 3 parts, because coding, there's a lot to coding, and there's a lot of material that I usually cover in class. So today we covered how to set up an Arduino sketch. We talked about void setup. We talked about void loop and what those both entail, all the stuff that goes into those, how you define your pins in void setup as either an input or an output. And in void loop we talked about Jerry, right? So if you get confused as to how void loop works, think about Jerry. He's there to help you out. And so that's how void loop works, and that's all the preliminary stuff to setting up all your whole sketch. You know, show you where everything goes and where to place your code in. And then we started talking about variables, and we talked about variables, and we talked more about variables, and we really beat variables to death, I think, for like 15 minutes. So hopefully now you get a really great understanding of how variables work. If you're confused about anything in this video, as usual, go to the Slack chat. You can go to the PyCrafters website at pycrafters.com, and go to the contact page and ask me questions. You can shoot me an email by going to the contact page and you'll see the email address there. Or you could simply comment under this video and hopefully I'll see it. So, that's how you can ask me questions. Otherwise, you can move on to part 2, and then after that, part 3. So part 2, we're going to be getting into digital write, going to be getting into analog and digital devices, and all sorts of stuff. So, hopefully you're not too confused, and we will see you in the next part.